This is part 5 of section 5.5. I want to solve cosine of 2x minus pi over 4 is equal to sine of x. Now this is the first time we've had two different trig functions in the same equation. So we've had sine and sine, we've had cosine and cosine, but now we have cosine and sine. I'm going to make a substitution. Since cosine and sine are cofunctions, I know that sine of x is the same thing as cosine of pi over 2 minus x. It's one of our cofunction identities. So the equation I need to solve is that. Okay? Now I'm going to treat this whole thing as our alpha. So one set of solutions is going to come from 2x minus pi over 4 equal to pi over 2 minus x plus 2n pi. Our second set of solutions will come from 2x minus pi over 4 is equal to 2 pi minus all of this plus 2n pi. Okay, so if we add x here and we add pi over 4 here, then we get 3x is equal to 3 pi over 4 plus 2n pi. And then if we divide everything by 3, we get x is equal to pi over 4 plus 2/3 n pi. Now here, distribute your negative. Okay. And I have 2x minus pi over 4 is equal to 2 pi minus pi over 2 would be 3 pi, 7 pi. No, I'm sorry. It's 3 pi over 2. I'm ahead of myself. Plus 2n pi. Now add pi over 4. And that gives you 7 pi over 4 plus 2n pi. Oh, I left off the plus x. There's a plus x right in there. There's a plus x right in there. So subtract and you get x is equal to 7 pi over 4 plus 2n pi. Okay, so now let's just find all of our possibilities. If our n is 0, we have pi over 4 here. If n is 1 and we add 2/3 pi, we get 11 pi over 12. And then if we add 2/3 pi again, we get 19 pi over 12. And that's all we get from this one. From here, this is positive, and if we add 2 pi, we're going to be too large. So the only answer we get is when n is 0, so we have 7 pi over 4. Those are our 4 solutions. Okay, so everything we learned about algebra still applies. So it is possible that we have something sort of quadratic in form, and we need to use the tricks we learned in algebra. And so we have the zero product property. If we look right here, if we want to find all the solutions in the interval 0 to 2 pi, and we are given 2 times cosine x plus 1 times the square root of 3 tangent x minus 1 equals 0. we have two things multiplied together equal to 0, so we can set each of these factors equal to 0 and solve. Okay, so solving this for cosine x, cosine of x is -1/2. So find the inverse cosine of -1/2, and you get 2 pi over 3. So your solutions from here, you have x is equal to 2 pi over 3 plus 2n pi. Or, since this is cosine, your x will be 2 pi minus 2 pi over 3 plus 2n pi. And that ends up being, what, 4 pi? Yeah. 4 pi over 3. Okay, so these are the solutions that come from this first factor. Now set this equal to 0, and you get tangent of x is equal to 1 over the square root of 3, which is square root 3 over 3. Inverse tangent of square root 3 over 3 is pi over 6. And for tangent, we get our x is equal to pi over 6 plus n pi. So here, if our n is 0, we get 2 pi over 3. And if our n is 1, we're adding 2 pi, which makes it too large. Here, if our n is 0, we have 4 pi over 3. And if we add 2 pi, it's too large. If our n is 0, we have pi over 6. And if we add pi to that, we get 7 pi over 6. And then if we add pi again, then we're too large. So these are our 4 solutions. Let's do the same thing here. We have two factors multiplied together, set equal to 0. So we're going to set each one equal to 0. If I set this equal to 0, I'll end up with secant of x is equal to add 2, divide by square root 3. Okay? And I could rationalize this, but since I want to use sine, cosine, or tangent, I'm just going to go on and say that this means cosine of x is equal to the square root of 3 over 2. This would mean that cotangent of x is equal to -1 over the square root of 3, which means that tangent of x is equal to the negative square root 3. So these are the two equations I really need to solve. Inverse cosine of square root 3 over 2 is pi over 6. So our solutions from this one are pi over 6 plus 2n pi, or 2 pi minus pi over 6 plus 2n pi. And that will and that ends up being 11 pi over 6 plus 2n pi. Now, inverse tangent of negative square root 3 gives me a solution of negative pi over 3. Now, for tangent, our x values are our alpha, which is negative pi over 3 plus n pi. Okay, so our solutions. Here we have pi over 6 that comes when n is 0. And if n is 1, we're adding 2 pi, which makes it too large. If n is 0 here, we have 11 pi over 6. And then if we add 2 pi, then we're too large. Here, if our n is 0, we have a negative, which is too small. If n is 1, so if we add pi to pi over 3, then we get 2 pi over 3. And then if we add pi again, we get 5 pi over 3. So those are all of our solutions. Now, we've had one problem where we had a mixture of sine and cosine, and we used a cofunction identity. But in general, if we have more than one, then we're going to look to our identities and hope to make a substitution to make the rest of our problem look easier.